Chapter 4, Exercise 6.1. A boy who is standing at the top of a well drops a stone into the well. The stone hits the surface of the water in the well 1.80 seconds after the stone is dropped. So as usual, always start by drawing a diagram. So this is the well. Now you need to define a y-axis. And so you need to get your toolbox and use something to draw a straight line. Okay, define your y-axis. And now you need to define an origin. So you can choose this, or you can choose the bottom of the well. It's up to you. I will choose the bottom of the well as my origin. Well, actually, no, I'm going to use the surface of the water. So this is the water level in the well. This is going to be my origin. So the boy is standing over here, and he throws. Oh no, he drops the ball, which is going to fall down like this. So when you see drops, that means that there is no initial throw. So it means that the initial velocity is 0. They give you the time t. Question A. What is the velocity vector of the stone just before the stone hits the water? So what you want to know is the velocity right here, v. So you know v initial, you know the time, and you want to find v. So which equation are you going to use? You can use this one. Vy is Vy initial plus Ay times t. This is a case of free fall. How do I know? That's because it's a stone. And usually when you throw a stone, you can more or less neglect air drag. If you neglect air drag and you drop an object, then the only force is Fg. So this is a case of free fall. And when you're in free fall, you know that the acceleration is 9.81 down. So which can also be written as A along the y-axis is negative 9.81. That's another way of saying it. Okay, so now you go back to your equation, and Vy is Vy initial, which is 0, plus the acceleration, which is negative 9.81 meters per second squared, time the time it took to reach that point, which is 1.80 seconds. And that's how you find the answer. So just give me a sec. I found negative 17.7 meters per second j hat. If I write it in that format, I should actually not say j hat. I should say that this is the v vector. There should be an arrow on top of it, like this. So I'm going to have to erase everything to calculate the acceleration. No, sorry, to calculate the displacement. To figure out the displacement, which is the change in position from the initial position to the final position, I need to figure out the initial position, which is this one. I know that final position is initial position plus Vy initial times time plus half Ay times t squared. So the final position is 0. Y initial is my unknown. Vy initial is 0 times time plus half. The acceleration is negative 9.81 meters per second squared times the time. Don't forget the square over here. Most people do. 1.80 seconds. And then you move all of these to the other side. And that gives you a Y initial equal to 15.9 meters. So now you know that the distance between that point and that point is 15.9 meters. Your displacement is a vector, so it's 15.9 meters, but the displacement is down, so negative 15.9 meters j hat. That's your displacement.